Consider the bounded region between these two quadratic functions, negative x minus 3 squared plus 9 and x minus 3 squared plus 7. Now, I feel like you already know what I'm about to do. As soon as I know that there's a region involved between these two functions, right away I'm going to get my picture going. So here is x equals 3, and f of x is a function that opens down with vertex at 3, 9. Meanwhile, g of x has its vertex at 3, 7, slightly further below, and it's going to open upward. We're going to now take the region between these two functions, and we're not going to spin it around an axis at all. We are going to spin it around a slightly shifted line, y equals 3. Y equals 3. So that line will come in right here in blue. Y equals 3. We are going to spin the region around that line. So for example, at some x value here, I will spin green around the blue line, and I will spin red around the blue line. Give a little bit of depth. With green, give a little bit of depth. And the area of the washer-shaped region between those two would be the area of this particular cross section. Now, the interesting thing about this particular example is that, okay, the cross section is still a washer. So the area of the cross section at this particular x value is still going to have the same general format of big radius squared take away little radius squared. Where it becomes interesting is actually trying to figure out what is big radius and what is little radius. Because this time, the little radius, for example, is not exactly equal to the output of the function. The little radius is the difference between the output of the function and the y value that we're spinning around. The length of this inner line segment stretches from the output of the red function to the blue line. So the little radius is equal to the output of g of x, the red function, take away y equals 3 to find the distance between those two, g of x minus 3. Likewise, the big radius of this washer-shaped region is not equal to the output of the green function f of x. It's equal to the difference between the green function f of x and the starting y value of 3. It's equal to the difference between those two values. In other words, our big radius is given by negative x minus 3 squared plus 9. That's f of x. Take away 3. That's the y value of the line that we're spinning around. Once again, I strongly recommend that you not just try and memorize what to do in all of these different cases. Spin around the x-axis, spin around the y-axis, spin around y equals 5. Try to draw a picture and use the picture and your deductive reasoning skills to find reasonable expressions for the outer and the inner radius of this washer-shaped region that you're creating. We can integrate from the lower and the upper values of the region. We can integrate big radius squared, we can integrate big radius squared, f of x minus 3 squared, and then we can take away little radius squared. So here's little radius squared, which we found by doing g of x minus 3. To finish this up, our next step would be to actually figure out these limits of integration. And as usual, the limits of integration will be the x values where f of x and g of x cross each other. They will be the limits, the x values where the red function meets the green function.